Hello everybody, welcome to this AU presentation configuring AutoCAD Plan 3D Isometrics. My name is Bernd Gerstenberger. I am a senior technical support specialist at Autodesk. With my colleagues, I'm hosting the blog In the Pipes and the video blog series Plan 3D with experts. I'm living in Munich, Germany. So this was about me. Um, But what about this presentation? After this presentation, you will know how to use all isometric configuration files for your needs. At the end of this class, you will have got an overview of the configuration files for isometric drawings. You are able to use user-defined components. You can configure the IsoConfig XML, and you can set up additional customization for isometrics. All in all, you will be able to configure the isometrics to your needs. Let us start with an overview of the configuration files for isometric drawings. When you're switching in Windows Explorer to the project folder, you will see here a subfolder called isometric. Here, all isometric customization files are stored. We will find here several folders, which are the IsoStyle folders, and several XML and drawing files. Inside of the IsoStyle folders, we will find 3 additional files: the IsoConfig XML, the IsoATR, and IsoDWT. If an isometric drawing will be created by a specific IsoStyle, we will find additional files and subfolders here. Let's dive a bit deeper into the structure. The files, which are saved directly in a project subfolder isometric, are the isometric project files. They behave independently from an IsoStyle. Here we will find the following files: bold size mappings XML, ISO ASCII ARCAD block map XML, the ISO symbol styles drawing, the Plan 3D ISO symbols drawing, and finally the property translation mapping XML file. The ISO config XML file, the ISO ATR file, and the ISO DWT file are isometric style files. So they belong to a specific ISO style. We will talk about the ISO ASCII ARCAD block map XML and the ISO symbol styles drawing file in the next section when we will create a user-defined component for an isometric drawing. We will talk about the ISO config XML file in a separate section as well. About the other files, we will talk at the end when we will talk about additional customization for isometric drawings. Let's move to the next step: how to use user-defined components for isometric drawings. In this section, we will create a block-based component for a catalog. This will be added to a spec and finally be used in an AutoCAD Plan 3D model to create an isometric drawing. Therefore, we will adopt those files: the catalog file, which is a PCAD file, the spec files, and the isometric project files ISO ASCII ARCAD block map XML and ISO symbol styles drawing. The general process which we are following is converting an AutoCAD block in a piping component, creating a new catalog component, adding this component to a spec, adjusting of the ISO ASCII ARCAD block map XML, adjusting of the ISO symbol styles drawing, using the component in the model and creating the isometric drawing finally. Let us start. In this video, I'm showing you 2 blocks which should be used for a custom cap component in a catalog. One for the size 100 and the other one for the size 80. The drawing can be saved anywhere. It hasn't to be saved in the project itself, but it has to be saved. The running command plant part convert converts the block to a plant component. This command has to be executed for every size separately. When running it, I will be asked for adding a port. A cap has only one single port, so I'm adding only one port for each size component. The component will be finished using the option exit. Finally, I have created additional files which can be seen in the same location as the drawing. One XML file, and for each size a separate snapshot, which are ping files. When opening the XML file, you will see the count of added ports and the associated ping file for each block. Now we have to create a new component in the catalog and to add it to a spec. Let us watch this short video. So I'm selecting custom AutoCAD drawing block-based graphics, selecting miscellaneous and the component cap. I'm adding a metric component from a size range 80 till 100. I'm adding a short description, which is here AU cap, Autodesk cap. The primary end type I'm changing to Beveled. And now the port is just one port. Just clicking create. Now I have just to fill the mandatory fields like the long description family. Just a copy and paste here. As you can see, I have too many sizes, so I remove the unneeded one. So only 80 and 100 stays. For each size I'm adding the long description size. And I have to add for each size the mandatory field matching pipe outer diameter. Note that I have to select for each size a separate block. In the dialog to select the block, only those blocks are listed which have the same count of ports, like the component I'm just creating. The ISO symbol type is a hard-coded type. It is not possible to create a custom ISO symbol type. Look in the handout which ISO symbol types are available. In this case, we are using the type cap, which triggers that it closes at the end of the pipeline. Different to ASCII, just for training reasons, I'm using ASCII AU cap, which doesn't exist till now. We will adopt later the ISO ASCII ARCAD block map XML file to match an ISO block with this ASCII. So I have saved the component to a catalog, and afterwards I've added it to a current project spec. The custom cap is saved now in the project spec. Now we have to adopt some isometric project files. The mapping of the ASCII to the used ISO block will be done in the ISO ASCII ARCAD block map XML file. In the node ASCII map, two attributes are specified. The attribute ASCII is the ASCII of a component in the model. And the attribute ARCAD block maps a block of a file ISO symbol styles drawing to its ASCII. Wildcards can be used for ASCIIs. A question mark is representing only one single letter or number of a ASCII. There are some additional kind of ASCII maps for specific purposes. Please read the handout to get more information about them. For our task, we have to map the ASCII AU cap to an ISO symbol block. This will be done by adding a new ASCII map and mapping the block AU cap to its ASCII. The block EUCAP still doesn't exist. We have to create it. All ISO component blocks are saved in the ISO symbol styles drawing. We will open it with project setup, node isometric drawing settings, symbols and references, here by clicking button edit isometric symbols. We will open the standard cap block, adding a second line. And afterwards, we will save the block as EUCAP. Now we just have to create the model in the project and to generate a new isometric drawing. Here's our model. And here's the outcome. Note the second line of a cap, which means that the right new symbol was used. Now we are moving on to the next learning objective, configure the isoconfig XML file. Many settings for the isometric configuration can be done by the user interface of a project setup. But there are settings which cannot be configured at this place. These settings have to be set directly in the isoconfig XML file. Each ISO style gets its own configuration, and accordingly, it has its own isoconfig XML file. The isoconfig XML file is really a large file. Without any configuration of this file, you will note about nearly 3,500 rows. If you do not understand the structure of this file, you are lost. So let us talk about the structure of this file. Just a short side note, use a good XML editor like XML Notepad to edit this file. Otherwise, you won't be happy. The structure of this file can be seen most clearly in the tree structure. Looking to this image, you see the main text of this file. Let us talk about them. Output. Here, general settings for the output are configured, like, for example, the content of a bill of material should written in capital letter or not. Files. This is about paths and file specification of different configuration files. Normally, you are doing the changes here directly in project setup, not in an isoconfig XML file. Same for advanced default. During the creation of isometrics, you are able to specify the advanced ISO creation options. While these settings are temporarily for the current ISO creation, most of these options can be set permanently for this project in the user interface and here in the isoconfig XML file. File name format. Here you will do settings for the physical file name of a created isometric drawing. Drawing name format, which sounds similar, but it isn't. These settings are used for the drawing name in the title block. View. The settings for the north arrow, the table and the drawing areas are saved here. Geometry. Here are some settings about the geometry, like for example, if you are using gaps or not. Units. The setting for the position, but also general settings for metric and imperial units will be saved here. These settings will be used for dimensions mainly. Skew. These settings correspond to a node, sloped and offset piping in the dialog of a project setup. Split. Here you adjust by which criteria the isometric drawing should be split. Data. This is about data which will be shown in the tables. Table. The different table formats of a bill of material, the weld list, etc. will be defined here. Also, link to the data will be set. So to this node data again. Logging. This section is for formatting the log file of the isometric creation. Title block. List of the attributes which will be placed in the title block. Layout optimization. This section is for optimizing of annotations, dimensions, and the splitting of isometric drawings. Themes. This is the biggest node in the isoconfig XML file. A theme is a named configuration, especially for dimensions and annotations, but also for symbols, insulations, and bend and elbows. There's a main theme with the name default and some override themes. The override themes will be used if certain criteria are met. When the settings of the override theme will override the main theme, there are the following override themes. Small bore piping, fitting to fitting, van drain piping, offline instrument connection, existing piping, continuation and connection piping. The main settings for these override themes are about dimensions and annotations. The last tag is the filters tag. This tag will be used, or all the tags inside of this node, all the filters will be used to identify components which are used from the tags described before. Filters are used, for example, for table data, but also for the subnode dimensions and annotations in the theme node. Now, let us start to solve some tasks by configuring the isoconfig XML file to our needs. In this presentation, I'm only showing some less tasks, but you will find more tasks with a specific solutions in the handout. These tasks are new tasks and differ to a task which I have presented already in my 6-year-old class about configuring isometrics. Task 1. Separate PCF file per drawing. This is a new feature of version 2021. Create for each isometric sheet a separate PCF file. Let us watch this short video. To solve this task, we have to switch to the node output. Here's a tag called enable PCF per drawing. Let us turn the value of this tag to true. Don't forget to save the file. Now let us create an isometric drawing. When it is ready, note that 3 ISO sheets are created for this line number. Let us take a look in the ISO style folder. In the subnode prod ISO drawings, for every ISO sheet a separate PCF file is created. Note that in the ISO style subfolder PCFs, the normal PCF file of a whole isometric drawing will still be created. Task 2. Separating components in the BOM which have different values for property manufacturer. This task is about adding an additional property to a bill of material and getting separate rows for components with different values for this specific property. Let us try this with flanges. By default, all flanges with the same value of the item code and the same description are in one row. Flanges with value Autodesk, but also with a value Desk Auto for property manufacturer are listed as one row in the BOM. To change this, we have to adopt viisoconfig XML in Node data. But before, to make it more visible, we have to add a new column manufacturer to a bill of material. So this is a column. Come on. This is a column manufacturer. Now in the isoconfig XML file, we have to switch to a Node data aggregated lists, the one with name materials, groups, group with the name flanges. Here we have to add a new column called manufacturer. That's it. Just to save this, let us try. So watching this short video here. Here are two flanges which have a value Autodesk for the property field manufacturer. The other two flanges have a different value for the property manufacturer, which is desk auto. So without any configuration, we are just creating an isometric drawing. The flanges are listed in the bill of material in just one single row. And for the column manufacturer, we have both different values in one field, desk auto, Autodesk. Now we want to change this. In isoconfig XML, we are switching to a Node data, aggregated lists with the name materials. When we are groups, when we are looking for a group with the name flanges. In columns, we are just copying one of the existing columns and paste it into the same level. And here we're just changing the name to manufacturer. Don't forget to save. And now we are creating a new isometric drawing and see what happens. So just look in the bill of material. So the rows are split into two rows for two flanges in the second line and two flanges in the third line. The first two flanges have a value desk auto. Third and fourth flange do have the value Autodesk. In the handout, there are some more tasks which you can try to solve by your own. Also look into the old AU class with a lot of more tasks to train yourself. Let us move to the next learning objective, additional adjustments for isometric drawings. I'm talking about the isometric project files, bold size mapping XML, plan 3D ISO symbols drawing, and property translation mapping XML. Also about the isometric style files ISO-ATR and ISO-DWT. Let us start with bold size mapping XML and property translation XML. The first one will be used for two things, for mapping between British and metric bold set sizes, but also for setting of alias names for actuator directions. In the image at the top right, you see that the direction up will be set to use a German alias name oben. So here you see up, and by default, you have also here the value up. I have changed this to oben, which is the German word for up. The second XML file is similar to the first XML file and will be used for translation of properties. In this example, at the right side, the property operator will be translated to German Antrieb. If both files are changed in that way and you run an isometric drawing, the standard annotation operator up is translated to Antrieb oben. So by default, you will see here operator up, but we have translated it to Antrieb oben by configuring the isometrics to our needs. Next file, plan 3D ISO symbols drawing. This drawing contains the block definition of ISO messages and breakpoint markers. These blocks are used by both the 3D model and the isometric drawing. For example, the block plan P3D isosphere, this is this one, will be used for the creation of a breakpoint in the model here at the top. And so you see here the block definition here in the, on the right side and below the presentation in the model. The ISO drawing template will be used as a drawing template for isometric drawings. It is ISO style dependent. Every ISO style has its own ISO drawing template file. We will open it from a project setup, node, isometric drawing settings, title block and display, button, setup title block. The following will be saved here. Tables like the bill of material or the word list. The draw area and the node draw area. The north arrow, title block and its attribute mapping, LDT setting, several styles like text styles, dimension styles, and so on, and the layer configuration. Let us do another task. Adding an alternative dimension to the isometric drawing. So by default, you will see in a metric project just the metric units, numbers of a dimension in metric style. We want to add now additionally the dimensions in architectural style. If you're looking into the ISO config XML, you will find in node units dimension style that the metric projects are using the dimension style ADSK ISO metric, which is saved in the ISO DWT file, and it can be modified using command dim style. Let us watch this short video. So by default, we only see here in a metric project just the metric values for the dimensions. Now we are switching to isometric drawing settings, title block and setup, and we are clicking setup title block. We can enter just directly dim style, or we can click ISO themes in the ribbon bar. Now we have to select the ADSK isometric dimension style and click modify. Switching to tab alternate units, we are checking display alternate units, and for the format, we are switching to architectural. That's it. Just saving the file. Now let us try. So when creating a new isometric drawing using the modified ISO style, the alternative dimension will be shown. So finally, let us talk about the ISO ATR file. The file extension ATR stands for attribute. The ISO ATR is divided into two halves, the section attributes and the section BOM attributes. The title block uses only attributes from the section attributes. Only the following properties are evaluated from here: project properties, drawing properties, pipeline group properties, not segment, and LDT properties. The line number scheme of the ISO config XML access throughout the tag line field to these properties. All other properties have to be specified in the bottom section, BOM attributes, for evaluation. They will be used for annotations or tables. On these properties, the line number scheme access throughout the tag component field. Other annotation schemes like component schemes are using the tag field to access to all properties from this file. With all properties, I mean properties from section BOM attributes, and attributes. Let us execute another task. Exporting specific class properties to a PCF file. PCF file will be used for data exchange with different applications. By default, several class properties like material or pressure class are already saved in a PCF file. Now the task is to add other properties to a PCF file. In this case, we will add the property wall thickness to the PCF file. Wall thickness is a property of the class piping and equipment. This class will be called engineering items in ISO ATR. So it has to be added as engineering items dot wall thickness to a section BOM attributes. After all is said, we have to create an isometric drawing and have to look for the created PCF file. See here that the property wall thickness is added with a value, which is here 3.6. So let us watch again a video. In Data Manager, you see for the elbow that it will have the value 6.3 for wall thickness, and the pipes have the value 3.6 for wall thickness. So let us switch into the ISO style and changing the ISO ATR file by adding engineering items dot wall thickness. Don't forget to save. Now we have to create a new ISO, production ISO, selecting the specific changed modified ISO style. The ISO drawing is created, but we are not looking for the ISO drawing, but for a PCF file, opening it with Notepad. And here you see, for example, for pipe component that the wall thickness property is added here with a value 3.6. And if you're looking a little bit higher, you will see here that the thickness for the piping band is 6.3. So we are at the end of a presentation. I hope it was useful for you. And now you are able to configure isometric drawings to your needs. This last slide shows you some useful links. So the blog in the pipes, where the technical support and premium support is posting several posts about AutoCAD Plan 3D. Also the link to a video blog series, Plan 3D with Experts, which has started last year in September. And we have now a collection about 15 or 16 videos published. The videos do have a length between 5 and 15 minutes. Then a video collection about configuring AutoCAD Plan 3D isometrics, and also the handout of my old isometric class, configuring AutoCAD Plan 3D isometrics. And last but not least, the Autodesk Knowledge Network, where you will find several thousand articles just about AutoCAD Plan 3D, and a lot of them are about isometric stuff. Just look for them. You can also Google for them. So that's it. Have a great day. Goodbye. Your Bernd Gerstenberger.